Hi, welcome to Dice classes. Today we can continue with the concept of vectors dot product. In last video, we explained dot product between two vectors a dot b is equal to mod a mod b cos theta. From this we can find cos theta. Cos theta equals a dot b divided by mod a into mod b. Children, why can't you call it as a cap, unit vector? Why can't you call it as b cap? So it is actually a cap dot b cap. Cos theta can be expressed a cap dot b cap. Next, what is a dot a? A dot a is mod a square. For mod a square can be either greater than or equal to 0. So if a is a zero vector, then a dot a becomes 0. For non-zero vectors, if it is non-zero vector, means magnitude cannot be 0, a dot a will be greater than 0. You cannot equate with 0. What is a plus b dot a minus b? A plus b vector dot a minus b vector. You can calculate a dot a, that is mod a square, a dot b, b dot a. Dot product satisfies commutative property. Means a dot b vector will be equal to b dot a vector. So using that concept, the answer is mod a square minus mod b square. What about modulus of a plus b whole square? That is nothing but, so whenever mod a square is there, it is the dot product of two same vector. So mod a plus b square means it is the dot product of two same vector. Which are the vectors? A plus b dot a plus b. So a plus b dot a plus b is mod a plus b square. What is the answer? And just remember our identity, what we learned in the lower class. A plus b whole square. A square. Instead of a square, mod a square. B square, mod b square. Plus 2ab in algebra. But we will call it as a dot b. Then what is a minus b whole square? Mod a square plus mod b square minus 2a dot b. When vectors a and b are perpendicular, a dot b becomes 0. Then this term and this term becomes 0. Then mod a square plus mod b square will be the right side for both. That means modulus of a plus b vector will be equal to modulus of a minus b vector. Then the angle between them, theta, is 90 degree, a very important relation. That is, magnitude of sum of the vectors equals magnitude of the difference of the same vectors. Then the vectors are mutually perpendicular. What is a plus b plus c modulus whole square? A plus b plus c modulus square. Again remember algebra result. Mod a square plus mod b square plus mod c square plus twice a dot b plus b dot c plus c dot a. Even I can write this term as sigma a dot b. Sigma a dot b means a dot b plus b dot c plus c dot a. If a vector is perpendicular to b vector, perpendicular to c vector, perpendicular to a vector, that means a, b, c are mutually perpendicular. Then dot product a dot b, b dot c, c dot a becomes 0, vanishes. Vanishes means it becomes 0. Then mod a plus b plus c whole square is equal to, this whole term is 0 means remaining is mod a square plus mod b square plus mod c square. This will be the answer when the vectors are mutually perpendicular. if the statement carries one vector is perpendicular to sum of the other two vectors, means A vector is perpendicular to sum of other two vectors B and C. What does it mean? A perpendicular to B plus C means A dot B plus C will be pseudo vector. Sorry, pseudo. It is not a vector because dot product is not a vector. A dot B plus C is 0. Then B perpendicular to C plus C. C perpendicular to A plus B. Then by adding everything, you will get all the three vectors are getting mutually perpendicular. You will get the same condition. Twice A dot B plus B dot C plus C dot A becomes 0 means vectors are mutually perpendicular. So same thing we will get when you take B is perpendicular to C plus A condition. C is perpendicular to A plus B, you will get the condition. Add up, you will get the same thing. So one vector is perpendicular to sum of the other two vectors means three vectors are mutually perpendicular. Then you can use the same condition. Okay. Now let us see. What is when by I dot I cap dot I cap is 1, that is equal to J cap dot J cap, that is equal to K cap dot K cap. They are collinear vectors. What about I cap dot J cap? 0, not 0 vector. Dot product of two mutually perpendicular vectors, always 0. I dot J 0, J dot K 0, K dot I 0, because all these are mutually perpendicular vectors only. Next, we can see the cross product between the vectors. Cross product has another name, that is vector product. Cross product or vector product. When there is a vector A, here is a vector B, then theta is the angle between them. Then A cross B is a new vector which is perpendicular to vector A and vector B. Its direction, we can use right hand palm rule or right hand screw rule. See, palm rule, if you use, curl your fingers from vector A to vector B. So this is the way it is curling. Then thumb shows upward direction. So this is the direction of A cross B. A cross B. Then this is the direction of B cross A. So A cross B vector is not equal to B cross A because magnitude is same but direction is different. So vector A cross B is negative of B cross A. That means cross product does not satisfy its commutative property, but dot product satisfies commutative property. So this is 90, this angle is 90. Now if vector C is equal to A cross B, what is angle between C vector and A vector? C vector and A vector 90 degree angle. C vector, B vector angle 90 degree because this is your C. This is your C. So C is making angle 90 degree with A. C is making 90 degree with B. Now A cross B is the vector perpendicular to the plane containing vector A and B. So if A and B is marked in a plane like this, see, this is the plane where A vector, B vector is present. Perpendicular to the plane, what vector you can consider? A cross B vector or B cross A vector. Both are perpendicular to the plane of the vector where A and B are present. Okay. Now, what is expression for finding A cross B? Modulus of A, modulus of B, sine theta. Up to here it is a pure scalar quantity, followed by n cap. N cap is a unit vector perpendicular to both A and B along the direction of A cross. So this is n cap vector. What is magnitude of A cross B? Mod A, mod B, sine theta. N cap magnitude, all of it is 1 only. From here we can find sine theta. Sine theta is mod of A cross B divided by mod A into mod B. Now there is a wonderful relation connecting dot product and cross product. The relation is modulus of A cross B square plus modulus of A dot B square is equal to mod A square into mod B square. So even you can expect numericals based on this. They can give A cross B, they can give mod B, then find A dot B square. Substitute and get the value of modulus. So modulus of a vector never becomes negative, remember. So if mod A square is equal to 16, then modulus of A is, don't say plus or minus 16, it must be modulus of A should be plus or minus, never comes, it should be positive only, so it is plus 4 only, not take plus or minus 4. Now, what are the geometrical interpretation? I cross J. What is I cross J? K vector. J cross K, I vector. Then K cross I, J vector. If it is interchange like J cross I minus K. K cross J minus I cross K minus J. It goes like that. Then A dot I, where A is a non-zero vector. A dot J plus A dot K. The answer is vector A only. You can remember the result. Similarly, modulus of A cross I square plus, where A is a non-zero vector. A cross J square plus A cross K square will be 2 mod A square. 2 mod A square is another wonderful relation. What is A minus B vector cross A plus B vector? We know first A cross A, cross product between two similar vectors. That means collinear vectors are always 0. It is a 0 vector. So A cross A, 0 vector. Then A cross B, that is plus A cross B minus B cross A plus 0 vector or minus 0 vector. We studied A cross B minus B cross A is plus A cross B. So answer is 2A cross B. Sometimes question will be there. A minus B cross A plus B equal to lambda into A cross B, then value of lambda. So for all these kind of questions, you just expand and change minus B cross A by plus A cross B. Finally, how much you are getting? If it is 2 A cross B, lambda is 2. If you are getting 5 A cross B, lambda is 5. That way you can solve those kind of questions. Now, next step, we can consider the geometrical meaning of cross product. Geometrical meaning means when sides of a triangle are represented by vector A and vector B. See, vector A, vector B are the sides of a triangle, then third side is here. Then area is equal to half modulus of vector A cross B is the area of this triangle. When vertices of the triangle are given, say A, B, C are the vertices coordinate like 1, 2, 3, 3, 5, 6, same way. Then find vector AB, find vector AC. Then area is half AB vector cross AC vector. How to find AB? You can find AB with OB minus OA. You can find AC with OC minus OA. Subtract the values, get AB, get AC, Determinant. While finding determinant, you can use ijk in the first row, second row AB vector components, third row AC vector components. What about area of a parallelogram? When parallelogram is represented by sides A, side B, then area is mod of A cross B. There is no half. When diagonals are given, say D1, D2 are the diagonals, then area is equal to half D1 cross D2 when diagonals are given, half into modulus of D1 cross D2. When vertices are given, see A, B, C, D, it can be coordinates or position vector of A, B, C, D, whatever way they can give. Such cases, what will be the area? Very simple, like the previous one in the case of triangle, what we did. Find vector AB, find vector AD. A I am taking as a common thing, okay? Then area will be, when sides are given, area is A cross B. Here instead of A cross B, we can take AB vector cross AD vector. These are the two sides. Again, AB is OB minus OA, AD is OD minus OA. So area of a rectangle, area of a square, area of a parallelogram, area of a rhombus, all these questions we can solve with the same concept. Next, so these are geometrical applications.